Welcome to the very first episode of the Nutritious Minds Podcast. I am Dr. Rachel Gao, child neuropsychologist, researcher, lecturer, registered nutritionist with a background in nutritional neuroscience. I'm also the founder of Nutritious Minds Trust Charity and Nutritious Minds Clinic, as well as the author of Smart Foods for ADHD and Brain Health. So my work sits at the intersection of nutrition, neuroscience, child development, neurodiversity, brain health, and education. So I'm very excited because today's episode is about the future of brain health, how we can protect, nourish, and support the brain across the lifespan. Dr. Michael Crawford is my guest of honour today. He was also my external PhD supervisor. He trained and guided my research in nutritional biochemistry. His work has deeply changed the way I think about the brain, and many others too, and also the way that we look at the health of the mother, their children, and the wider domain of public health. So Michael is approaching his 96th birthday in July, and it's a real honour to begin the Nutritious Minds podcast with you. So I'd just like to take a moment to introduce you, Michael, if that's okay.
Thank you.
Professor Michael Crawford is one of the world's pioneering scientists in maternal nutrition, omega-3 fatty acids, docosahexaenoic acid, also known as DHA, which is going to be explained in detail, so bear with us, arachidonic acid, brain development, and nutritional biochemistry. He studied chemistry at Edinburgh University and completed his PhD in chemical pathology at the University of London. His career has taken him from London to Uganda, Japan, Oman, the United States, Europe, and many international scientific platforms. Michael has contributed to the WHO, the FAO, expert consultations, advised on food and health policy internationally, including work linked to Japan, and I've mentioned Oman already. Michael founded the Mother and Child Foundation charity, which he's going to be speaking about, and has been the recipient of countless awards and major international honours. So today we also want to hear about Michael the person, husband, father, grandfather, global traveller, scientist, thinker, friend, and storyteller. So without further ado, welcome Professor Michael Crawford.
Thank you, Rachel.
How are you doing today?
I'm doing fine. Just
good.
Yes.
Settling in,
enjoying the tea.
Good. Michael, I want to begin with you as a person. At 95, when you look back over your life, what are you most proud of?
That's very, very difficult.
Yeah.
I suppose I'm most proud of the children.
Yes.
Both Lindsay, who became a nurse in New Zealand, and Adam, who became Professor of Criminology at Leeds University. And, so these were our two children born to us.
Yes.
And I'm very proud of both of them.
Of course, absolutely. So let's start right back at the beginning. Can you tell us where you grew up? Maybe a little bit about your childhood. One of the most favourite stories that I love to hear during our countless meetings at the Royal Society of Medicine is the story of how your parents met. Would you be willing to share a little bit about that story?
It is, of course, a lovely romantic story. Well, my father was an accountant before the First World War, and he was a great horseman. And so when war broke out, he joined up the army, and they put him as captain in charge of the horse artillery.
Yeah.
And he took a whole team of howitzer guns and things like that, driven by horse. He led them through France to the Battle of the Somme.
Incredible.
And he told me that when he arrived at the Battle of the Somme, there was a great cry came up from the trenches. The guns, thank God, the guns.
Gosh.
And he said he was very proud to be able to deliver all the big guns to the front line of the Somme.
Yes.
But then, unfortunately, he got shot off his horse by a sniper.
Yeah.
As they tend to pick up the leaders of things and so on. He was treated in a field hospital, and then he was sent back to Norfolk Hospital, War Hospital, where he was treated and brought back to health and stability by a beautiful nurse who, after the war, they married. And so she became my mother. Oh. And so that was really lovely.
Yeah, that's such a beautiful story. That's wonderful. So was there a moment when science first captured your imagination? As a child, did you ever dream that you were going to become a scientist?
Well, I was always interested in chemistry. I had chemistry sets when I was small.
Yes.
And things like that. And I used to build radios, and so I was into electronics, and I tried to build a transmitter, and I was told I was not allowed to.
Oh, gosh.
But yes, I for some reason or other, don't ask me why, I have no explanation for it, but I was just interested in chemistry, the way that things worked.
Yes.
Putting them together.
Yes. And then you also lived and worked in Uganda at is it the Makerere University?
Yes.
Yes.
The medical school at Makerere, yes.
And what was life like there?
Oh, it was
Tell
fabulous.
us. Yeah.
These were some of the best years of my life.
I can imagine.
I had no intention of going to Uganda, but Sir John McMichael heard that I wanted to travel abroad. He was head of medicine at the postgraduate medical school in Hammersmith, where I had done my doctorate.
Yes.
And he took me into his office one day, and he'd just been out examining the medical school at Makerere in Kampala, which was part of London University, and London University supervised all the degrees and everything. And he'd just been out there examining, and he showed me pictures of Uganda, and it just blew my mind. And he said, the most interesting thing you'll find as a researcher, because he knew I'd been very much involved in biomedical research at Hammersmith, he said, the most interesting thing you'll find is they don't have any heart disease. And when I went there, I discovered Jack Davis, who was Professor of Pathology. I got quite friendly with him quite quickly. And because my job was to set up biochemistry and chemical pathology teaching at the medical school. And Jack told me, he said, it's not just that they don't have heart disease, they don't have breast cancer, they don't have colon cancer.
Incredible.
And he said the problem is that nobody really believes us, because they think we're just sort of a bunch of hicks drinking our gin and tonics as the sun sets. But so he got a whole bunch of specialists from the National Institutes of Health in America to come to Uganda to set up a cancer registry. And it was 100% true that they really did not have breast cancer, colon cancer. And so this was really, it set up a whole bunch of research problems that I enjoyed while I was in Uganda.
Yes, and you used to swim in the lakes there as well, didn't you?
What's that?
You used to swim in the lake.
Oh.
I remember you telling me about the lovely lake.
Lake Victoria.
Lake Victoria, yes.
Rex Dean was head of the infant malnutrition unit, and he used to take us to a special place where there was no bilharzia, so he said. And we used to go and have picnics on a Sunday sometimes and have a swim in the Lake Victoria. And I think the problem was that I was a keen swimmer, so when I swam further than I should have done, and I contracted bilharzia in that. So that was another horrendous situation.
So, Michael, you recently published The Shrinking Brain and the Global Mental Health Crisis, of which we have a copy on the table there, 2 problems, 1 solution. When did you first begin to become interested in the human brain and, more importantly, the nutritional composition of the human brain? Perhaps you can tell us a little bit more about that?
It was really terribly simple because I'd had such fun doing research in Uganda and working out various things and discovering the importance of aflatoxin and primary carcinoma and this kind of stuff. And so when we were there for set up functions and things like that, and we weren't supposed to be there for long term because we were training people to take over.
Yes.
Excuse me.
It's okay.
And so I was offered this job at the Nuffield Institute of Comparative Medicine as head of biochemistry. And I was given, this is from 1965, I was given money to buy equipment, £30,000, which in those days was a lot of money.
Definitely.
And I had staff, and we sat round the table one day and said, well, now, what are we going to do with all this lovely equipment I'd been buying? And, we can't really... I've said something about the fact that I couldn't believe the amount of fat that people were eating in this country after having spent 5 years in Uganda. And I said, I wrote a paper to the Lancet about it, and funnily enough, and I said, we should be working on fats, but everybody's working on fats. And then Gail said to me, but the brain is made of fats. Why don't we work on the brain? So I said, yes, brilliant. Let's do that.
Excellent. And to put it into context, I think it was in 1954 that Hugh Sinclair had also submitted a publication. Was it published in The Lancet, I believe? But correct me if I'm wrong. Drawing the links between nutrition and what he described as diseases of Western civilization.
Yes.
And of course, he was at Oxford at the time, and it wasn't well received, the paper, I believe. But
that's yes, go on.
So it's around the same time, your focus also turned to looking at the brain and specifically the nutritional composition in terms of lipids.
Right.
Yeah, so tell us more. What did you find?
Well, I mean, as far as Hugh was concerned, I mean, he got thrown out of Oxford because of his interest.
He was ahead of his time.
Published a paper called Atherosclerosis, etc., and he claimed that it was an essential fatty acid deficiency.
That's right, he did.
And he got thrown out of Oxford for that.
Yeah.
It shows you just how nasty it was, protective of the food industry being protective.
Yeah, very competitive as well. And of course, we now have the Hugh Sinclair department at Reading, don't we? So we have an entire laboratory named after him.
He came to I was asked by the Zoological Society to hold a conference on comparative nutrition.
Yes.
And which was published, volume 25, the Zoological Society Reviews. And he gave a paper, which, this is 1966 or thereabouts.
Yes.
He gave a paper in which he referred to docosahexaenoic acid and it's important for the vascular system.
Yes,
which was quite incredible. He was so far ahead of his time.
Yes.
And yet it wasn't until much later that we managed to get him reinstalled. But I was asked to create a conference on there was a sequence of conferences on essential fatty acid. One with Ralph Holman in the United States, and Ralph said, we need another one in London. So we had this one, and we invited Bengt Samuelsson, the Nobel Prize winner, and all that sort of thing. But we used his Nobel Prize as the excuse for the conference.
Yes, incredible.
And we had to turn people away from it.
I can imagine.
It was so popular. And so I got Hugh to give the final speech at the conference, and that he said he can now die in peace.
Oh, it's such a shame that we didn't have camera phones back then, because it would have been incredible to have watched that back now and to have replayed it.
Yeah. And for him to be talking about docosahexaenoic acid,
yes,
and it's all in that his speech, not speech as well. And
it was published, yes, you can download it.
Is in the Zoological Society reviews.
Yes. So I think we need to kind of go back to basics a little bit and tell our listeners, what is docosahexaenoic acid? Why is it important? Tell us a little bit about DHA.
Well, at the start, right back in when I first sort of joined the Nuffield in 1965, I hired Andrew Sinclair, and he and I decided that we really should find out what the brain fats were made of, and it was as simple as that.
Yes.
And we had gas liquid chromatography and all sorts of other things to enable us to
measure,
suss it out.
Yes.
And so we decided to do a study of 32 mammalian species, and we looked at the brains, the motor cortex, so the same for all species, and liver lipids, which would reflect the diet and everything. And the liver lipids were all over the place. I mean, they were just everywhere. But the brain from all 32 species was as identical as it possibly could be, bearing in mind analytical variations. And
identical in what way?
What?
Identical in what way?
Well, I mean, the fatty acid profile was identical, that they had arachidonic acid, adrenic acid, and docosahexaenoic acid. Docosahexaenoic acid was very prominent.
Yes.
A feature of all these brains, the motor cortex. And so the conclusion from that was that both arachidonic acid and docosahexaenoic acid were pretty important for the brain.
Yeah, brain essential.
And so we did studies in a primate, which were deprived of capuchin monkeys. We deprived them of all omega-3 fatty acids.
Yes.
And they went bananas.
Yes.
They indulged in the most severe self-harm. It was quite incredible.
Yes.
And at the time, the study was overseen by some kind of animal
behavior
thing, whatever it was. I can't remember the name of it. And they said, well, what you've got to do now is to give them back the omega-3 and see if it restores them, which we did.
Yes.
And then we had to deprive them again, and then we had to sacrifice them and study their livers and brains and things.
Yeah.
And so this was really the very first demonstration of the essentiality of omega-3 for behavioral problems in the brain.
Absolutely.
1973 published.
That was groundbreaking work because prior to that, like you've just mentioned, we understood that the omega-3 DHA was an essential fatty acid, an important part of our brain cells. However, it was considered more to be a structural fatty acid from the work of Bohr in around 1932. Their work, we knew that it was important structurally in terms of the structure of the cell membranes. But your publications in monkeys showing that depriving monkeys of alpha-linoleic acid and other omega-3 fatty acids resulted in these behaviour pathologies, and the monkeys were self-harming. They were injuring themselves and other members of their community, and then putting omega-3 back into the diet restored those behaviour pathologies. I mean, that was absolutely fascinating, and of course had implications for human behaviour. So what came next?
Well, it was quite funny because we had the whole of Unilever laboratories coming to visit us over this study that we were doing.
The findings.
And the pathologists kept on looking at the slides that Dick Fines had produced. He was the veterinary pathologist.
Yes.
And he came up with a classic remark. He said, "This is not a linoleic acid deficiency."
What did he think it was?
Well, that's right. And we told him, yes, it's an omega-3 deficiency.
Yes, yes.
So that was the end of that story. But
So now we understand that DHA and arachidonic acid are not optional extras. They are a key part of the structure, especially of the developing brain as well. So for a parent or a midwife or a young doctor listening, how would you explain why DHA matters?
Well, where it's actually found in the brain is in all the signaling membranes of the neurons and synapses. There's not much in the astrocytes. The astrocytes are arachidonic acid rich, not DHA rich.
Yes.
But docosahexaenoic acid is in all the signaling sites. And a lot of experimental work, both ours and across the pond in America and in Japan as well, all indicated that deprivation of omega-3, which influenced the concentration of docosahexaenoic acid, because there were no other omega-3 fatty acids in the brain. It's only docosahexaenoic acid. And these involved in, as we had shown, in behavioral disorders, poor learning, and Jean Anderson had produced some beautiful papers in 1973 demonstrating the effect of a deficiency of omega-3, and particularly DHA, on the visual system and on the electricity of the visual system. And that, of course, was just phenomenal work that he did.
Yes.
And subsequently, later, it was, there was all this stuff done in Dallas at the Retina Foundation, which Dennis Hoffman and his friends, and where they showed that it had these effects in preterm babies.
Yes.
And was able to demonstrate the significance of docosahexaenoic acid to visual acuity.
Absolutely.
So it's it's all there across the pond, and in Japan and in France and in Germany and in Norway. There's all these people in these different places were doing the same kind of work, demonstrating that. And it led to the Food and Agricultural Organization consultation in 2008 on the role of dietary fats and fatty acids in human nutrition. And in the publication, this was global, international experts in the field. And in the publication, it says that the evidence that docosahexaenoic acid is important for the brain is at the highest level of confidence.
Absolutely. We know that DHA and arachidonic acid are, to put simply, the building blocks of the baby's brain and retina. In fact, we wouldn't see in colour were it not for DHA comprising most of the rods and cones in the human brain. But I want to go back a little bit. So we recently saw David Attenborough's 100th birthday, which is phenomenal. He's just a little bit older than you, and he's our national treasure, but you are too. You are considered
not in
the grandfather, if you like, of omega-3 research, fatty acids and lipids. And in fact, you're friends of David Attenborough, and you once shared a discussion with him about vernix, the waxy substance that babies are born with. What was that conversation like, and what did it raise for you concerning evolution, fat, and the human infant?
Well, I've known David for a long time, and he wrote a foreword to my book on conservation in 1976.
Yes.
And we've been at several conferences together. It's, I mean, he held a BBC, unfortunately sound, so it's not so popular, but a sound program on the scars of evolution.
That's right.
Because Elaine Morgan had been writing. Now she's an author and playwright and all that kind of thing, done work for the BBC. And so she's not a scientist in any way, and she upset all the scientific community by writing a book which claimed that Homo sapiens evolved by water.
Yes.
And
the aquatic ape hypothesis.
And there's a ton of evidence to support that. And I gave a talk in the late 70s in the University of Washington, Department of Biochemistry. And I gave a talk, and somebody popped up and said, why on earth is this not all known?
Yeah, absolutely. So tell us, what is vernix and how is it?
People just didn't want to know about it.
Yes.
And it just upset so many characters. And so David held this two-part radio hour-long discussions on the scars of evolution. And the first part was all about Elaine Morgan and what she had written and why she all the criticisms that were being thrown at them. But the criticisms were mainly just vile remarks,
right?
Not scientific criticisms.
Yeah.
And David cottoned onto that. And then he had part two, and he opens part two saying that for a long time the idea that we had some kind of link with the seas and water was a subject of deep controversy.
Yes.
And he said, but this all began to change, and it began to change with the brain.
Yes.
And enter Michael Crawford.
Yes, yeah.
And so we had a long discussion about the significance of the marine food web because docosahexaenoic acid doesn't occur in modern land products. The stuff you get in the supermarket from land-based produced stuff doesn't contain any. It really is predominantly in the marine food web, where it occurs with also a bunch of trace elements, including iodine, which are important for the brain as well.
Yes.
So he started this thing off with all our brain stuff and so on. But he ended by saying, I wonder if there's an interesting fact that human babies are born with a layer of vernix, this fatty, waxy stuff covering their skin. And I know of no land-based mammal that is born with vernix. I wonder if marine mammals were born with vernix. And 2 weeks before the program was due to be on air, a professor from the University of British Columbia in Canada phoned David up and said, I hear you're interested to know. And I handle baby harbor seals. And he says, they're all covered in this waxy stuff, vernix.
Yeah.
And so that ended the program.
Yeah, fascinating.
And then I got hold of Tom Brenner, a friend of mine who worked at Cornell University at the time.
Yeah.
He was a mass spectrometry expert, one of the leading ones in the United States. And so Tom got hold of the vernix from 3 different marine mammals. The idea was that obviously it would be different chemistry.
Yeah.
And what he found was it was human vernix and the vernix from 3 different marine mammals was as identical as you can get.
Wow.
So I think that is a pretty strong clincher.
Yeah, pretty compelling evidence, arguably. So your former PhD student, Stephen Kinane, took this a little bit further, didn't he? And he developed the shore-based theory, which he spoke about in some depth in The Survival of the Fattest, his book.
Yeah.
And what can shorelines, lakes, rivers, coastal fossilized records teach us about brain evolution? Do you remember the exhibition we had at the Royal Society of Medicine during the DHA celebration meeting?
Yes, Stephen created that. It was really a wonderful exhibition.
Yes.
I mean, the back to that discussion at the University of Washington, a certain lady stood up after I'd been speaking and said, this is all right because I'm a geophysicist and all the geophysical evidence of what people described in terms of the fossils of the Rift Valley were all beside originally the ocean.
Yeah.
And towards the end, there was a big tectonic plate movement, a big sort of uprising, rather, and that separated the whole of the Rift Valley from the rest of the country and the oceans. And, of course, what that left was a string of lakes, very large lakes, and all these fossils that were found were basically living beside the lakes.
Yes.
And after all, it just makes sense.
Yeah.
Lucy was found with
right.
mussels and things, mussel shells all around her.
Catfish bones.
This was Lee Broadhurst.
That's right.
Subsequently became a great co-author in many of our papers about the significance of the marine food web to evolution of the human brain.
Yeah, it ruffled a few feathers because it had long been thought that we were hunters and gatherers out on the savannah plains, and obviously bringing human existence back to the lakes and the shores and the coastal regions.
The point about hunters and gathering stuff is they may have done some hunting.
Of course, they would have done some hunting.
But they would be pretty smart by then.
Yes.
I mean, they'd have to be.
Of course.
And, but the thing is that they would not, they might not be successful and turn up back at the camp with nothing to show for it.
Yes.
But the ladies pregnant or with children, nursing children, could just wander around the coastline and pick up food for free.
Yeah, absolutely.
And that food was full of all these trace elements and docosahexaenoic acid.
Yes.
And there's no way we could have evolved on the savannas of Africa.
No.
Because it simply doesn't provide the docosahexaenoic acid in the food web. And it is docosahexaenoic acid and the trace elements that go along with it.
Yes.
Were absolutely essential for the evolution of the brain.
Yes, and when we visited, we went to Isvaal in Stellenbosch in South Africa, do you remember?
Yeah.
And Randy Hartnell very kindly invited us to spend a couple of nights ahead of the conference at this beautiful location called Pinnacle Point, Mussel Bay, where we actually went to look at some of the artifacts from early human life dating back over 250,000 years ago with Peter Nielsen, was it?
Yes. Nielsen.
Yeah, and he gave us a tour of these caves, and that was quite incredible, wasn't it?
Incredible.
Yeah, wonderful memories. So your work has been recognised internationally. You received the gold medal at the first International Congress on Essential Fatty Acids. You received the Hoffmann-La Roche Award for your work on long-chain polyunsaturated fatty acids and infant brain development. You've also received the Gold Medal for Science and Peace and recognition from Oman for brain science and policy. What do these honours mean to you? Do you think, or has the world fully understood your message yet?
Well, I mean, obviously the awards one gets are deeply appreciated.
Yes.
And they bring you together with the people who gave you these awards. And it's the same with Isvaal and everything.
Yes.
It's just wonderful to have had these things and what can one say?
Absolutely. And also your work with marine agriculture. Do you want to mention a little bit about that?
Yes. That's quite important. In 1990, I was invited by the Japanese government to give lectures throughout Japanese universities on the importance of docosahexaenoic acid and its significance to the brain and its significance to the marine sea web. Because they said that we are worried about the Americanization of our traditional food system.
Yeah.
And I gave a lecture at the beginning in the Yamaha Hall, which was televised throughout the whole of Japan. And at the end of it, there were 2 weeks of all this wonderful stuff. I've been treated like just wonderful. at the end of it, there was a big meeting at the Japanese Ministry of Fisheries and Agriculture. And the minister sat at a long table with people up and down both sides. Doctor this and Professor this and Doctor that and Professor something else. All distinguished Japanese people. And the minister said, well, Professor Crawford, could you please just recount to us what you've been talking about for these last 2 weeks, the importance it has to our brain health. So I did. I gave him the spiel. And for a moment I thought the minister was not paying any attention to me. And then at the end of it, he brightened up and he said, "Thank you, Professor Crawford, for explaining why we should agriculturalize the oceans. And we will do that." And they've done it. Between two islands off Okayama, they have developed, they've cleaned up the seabed which had been destroyed by trawling.
Yes.
And was mostly mud. They cleaned that up, planted seagrass, so that the same way that we plant pastures for sheep and cattle, they planted seagrass for the fish.
Underwater, yeah.
Underwater.
Beautiful.
And they planted artificial reefs.
Yeah.
And they designed the artificial reefs in a way that there were individual reefs for the behaviour of the individual
fish
ecology of the different species that they were targeting. Seven different types of artificial reefs for 7 different types of fish that were targeted.
Amazing.
And these were planted, of course, in the deeper waters, one thing. And they've tripled the productivity of the area, whereas in outside regions, it has been falling.
Yeah.
Fishing catch has been falling. So that was a real success story.
Absolutely.
And it's the sort of thing we should be doing in the United Kingdom.
That's right, and that's part of your legacy,
yes.
Which is phenomenal.
It was incredible what they did. I managed to persuade the Omanis to do the same thing. And they have planted 350 hectares of artificial reefs.
Wow.
Just recently they sent me a video of showing how these artificial reefs, within 2 years, were populated with marine flora.
That's incredible.
And of course that does another interesting thing that one needs to think about, that planting kelp and planting these artificial reefs increases the surface area of photosynthesis.
Yes, that's right.
And so this could contribute to counteracting global warming.
And carbon emissions.
And providing food as well at the same time.
Yes, because oysters also play a role.
Well, oysters are just phenomenal.
Yes, and we used to be able to purchase oysters from the banks of the River Thames, didn't we?
Well, in 1990, the barman would gather the oysters in the morning in their buckets and put them on the bar free. There's a notice in the Museum of London showing that oysters free for those who buy our beer.
Yes, and now they're a delicacy, and they were once sort of served to prisoners, weren't they? And fish.
But it's possible to restore them, and they're showing that there's possibility in Maryland, because Maryland was once, they were harvesting 260 tons of oysters a year.
Now it's crabs.
And it diminished down to about 12 or something like that.
Yeah.
But they've started replanting the oysters, and they're absolutely amazed by how replanting the oysters is cleaning up the water.
Yes. And I remember actually I had my first oyster experience with you.
Oh.
And I can't remember who else was there. We were in Vancouver, again, at one of the ISFAL conferences. And I decided to pluck up the courage and try an oyster for the very first time. Yeah. I'd avoided them much of my adult life. And it was quite delicious.
If you remember, we had
it's like your brain's
buckets of oysters at my birthday party.
We did.
At the RSM.
Yes, that was outstanding. The 2-day DHA celebration meeting conference.
Which you organised, beautifully.
I helped organise, and that we hope to replicate in the not-so-distant future. But I would like to ask you about arguably one of your boldest ideas So in your paper on a quantum theory for DHA's role in neural cell signaling, you suggest that DHA may be irreplaceable because of its unique structure and possible quantum electronic properties. For listeners that are not scientists, how would you explain that simply? Why is DHA so special in the retina, in the brain, and for neuronal cell signaling?
Well, that's an interesting question.
Yes.
And we could go back to Gene Anderson's study in 1973, where he showed that loss of DHA in the photoreceptor resulted in a loss of electrical function.
Yes.
So that is the first clue.
Yeah.
And it's been confirmed time and time again.
Mm-hmm.
And so one needs to think about why is DHA so important. Mm-hmm. And then you have to realize that its precursor has got the same structure, but only 5 double bonds.
Yes.
And there's an omega-6, 22 carbon, same as DHA, with only 5 double bonds. Mm-hmm. So it's quite clear that 5 double bonds don't work.
Yeah.
So therefore it has to be 6 double bonds. So what could 6 double bonds be doing? And we've published a paper which we demonstrate the possibility that the 6 double bonds could be acting as a semiconductor.
Yeah.
And that, of course, opens a whole new ball game as to the way the brain functions.
Yes.
That the docosahexaenone is present in all the signaling systems. And we did studies showed that in the synapse, for example, if you fed synapses with
DHA,
all sorts of different fatty acids, it'd only take up DHA.
Yes.
And that was not only into the plasma membrane, it's also into the mitochondria and the microsomes of the synapses. Mm-hmm. Complete and absolute natural selection for DHA and DHA only.
Absolutely.
So it's clear that it is having a role such as we suggest. And it almost certainly was the first chromophore.
Yeah.
Because if you go back to the beginning of air-breathing life, there was no ozone layer. Mm-hmm. So the planet was pummeled by high-intensity ultraviolet from the sun. Mm. And the first living air-breathing systems, single-cell systems, one can think about the dinoflagellates, which would be very similar to what was the first systems, which has got a little eye spot.
Yes.
It's stuff full of DHA.
Yes.
And so the question is, would retinal be a photoreceptor? And the answer is no, because it would be blasted by the UV. So would DHA be the photoreceptor? Yes, it absorbs in the ultraviolet slap in the middle of the range that these first primitive systems would have been exposed to. Mm-hmm. And so we think that DHA was the first system which absorbed photons and converted them into electricity.
Yes.
And that's how it all started.
Yes, it's
and of course, when the air-breathing life got going and an ozone layer formed, then DHA could no longer work under those circumstances because it doesn't absorb in the visible. Mm-hmm. And then nature had to find another answer. And of course, she found out what we use today, which is retinal as the photoreceptor.
Yes. I mean, many believe that, Michael, you should have been awarded the Nobel Prize for your work on DHA and the evolution of the brain. And indeed, you believe that DHA played a role in brain expansion, which you write about so eloquently in the book, The Shrinking Brain. Does future neuroscience need to bring together nutrition, evolution, physics, quantum physics, and biology? What's the missing piece at the moment in terms of our
the missing piece,
the
missing piece at the moment is the application of the knowledge that we have
to
food policy and government policy. because if you look at the record of fish during World War II, fish and seafood was the only thing that wasn't rationed. And that changed in 1950 when everybody wanted to have production.
Absolutely.
And during the war, as a consequence of Hugh Sinclair visiting the Inuits and things like that, where all women who were pregnant or with children were given cod liver oil, milk, and orange juice free of charge, delivered by the milkman to her door.
Yeah.
I mean, this was incredible. And of course, all that went out the window and, after the war, with the thirst for production and land-based production. And fishing collapsed as well. The fish landing in what towards the end of the war was about 1 million tons into the UK, and in 2019 it was only 600,000 tons.
Yeah.
So it had dramatically dropped, and with it, per head consumption of fish and seafood has dropped. And with that, mental ill health has increased incredibly. And you've seen the Scottish report, which shows the escalation of autism in children with special needs. It's just going like that. I mean, it is just unbelievable. And what it really boils down to is associated with what we talk about in the shrinking brain.
Yeah.
I mean, the actual brain size is getting smaller.
Yeah.
I mean, even when I was first interested in the early 70s, the average brain size was about 1,450, about the same size as people in 160,000 years ago. Today it's 1,336. So even since the 1970s, there's been a very significant fall-off in brain size, and with it, an increase in mental ill health. And we've really got to realize that we're in a phase of reverse evolution.
Yes.
And that reverse evolution will lead to the end of Homo sapiens, without any doubt.
Yeah.
So we've really got to start thinking about it. We've really got to start doing what the Japanese were doing, fertilizing the ocean with marine grasses and artificial reefs and so on and so forth. Farming the sea has got to be number one, new productivity.
Restoring the oceans.
Restoring the oceans.
Yeah.
Restoring the seabed, restoring and increasing the productivity as well, and education of people so that they know why it's important.
Yes.
I mean, when I was growing up, if you ever went out for a posh meal, you always had 4 courses. There was always a starter, which often was
an amuse-bouche.
potted prawns or something like that.
Yeah.
And then you'd have a fish course.
Yeah.
And then you'd have a meat course. That's all gone.
Yeah, I mean, I don't know if Fish Friday is still a thing in primary schools or secondary schools, but I do remember that growing up. But yes, you're right. We'll come on to, the next generation and what's happening there with our guests who are waiting to join us shortly. But just finishing up, so when people look back on your life's work, what legacy would you like them most to remember? And what is a message, for example, that you would like to leave for your children, grandchildren, scientists, mothers, clinicians, policymakers?
It's difficult to think of. I think the most important thing is the saving the brain.
Saving the brain,
I think that is the most important.
Protecting the human brain.
Yes.
And how can we do that, Michael?
Because it's our children and their children that are at stake.
Absolutely.
And it is the most serious issue, and it's unattended.
Yeah. Yes, absolutely. Michael, thank you. That was beautiful and an important beginning. And we're now going to bring in 3 guests whose work connects with yours in different but complementary ways as we explore the future of brain health. Dr. Alex Richardson from Food and Behaviour Research is currently leading an important campaign on omega-3 in pregnancy, preterm birth, maternal nutrition and baby's brain health. Associate Professor Simon Dyall brings expertise in omega-3, DHA, EPA, arachidonic acid, lipid mediators, perinatal health, neuroscience, cognition and mental health across the lifespan. And Dr. Kevin Rigley brings a vital perspective on cognition, environment, childhood neurodiversity, and the conditions that help children develop and thrive.